Hello guys, so in today's video I'm gonna build Micrograd from scratch in C. In the last video I made about Micrograd, the code base was pretty simple, just scalar values autograd, but in this video I'm gonna build the whole neural network components of it, and we're gonna rewrite the whole scalar autograd code. So let's just begin. So here we have two files, scalar.c and scalar.h. H.h is a header file, which basically where we define our the blueprint of the code we are going to build in the C language. So yeah, it's pretty basic. We'll start with the basic format. Just like the last video, we are going to use struct named scalar, which would hold the value and the gradients and also the parent components. Okay, so yeah. Okay, so I've written the basic struct for storing the values and the respective gradients and the backward functions and everything. Okay, so here we have a data which is stored in a double data type, which is float 64 obviously, and then we have a grad, the previous struct which will basically hold the previous values associated to the new tensor, new scalar, and the previous size. This would define the size of the struct we are going to define, and this is the backward function, and this is the auxiliary value if we would need in some places. You will see. And now we'll define the functions that are associated to this scalar struct. So yeah, I'll just copy and paste it. Why waste time? Write it. So yeah, these are the functions that are associated to our scalar struct, which is basically we are going to use to perform some operation on the scalar. This scalar values. First one is to initialize. Basically, just like in Python, we have when we create a class, we have an initialize function. We are creating one initialize function over here also, and this is no operation backward, which is basically a null. And then adding function, backward of adding function, multiplying function, backward of multiplying function, power function, and backward of power function. Okay, yeah, so you can see we have three types of activation: ReLU, sigmoid, and tanh. Pretty basic ones. So now we need to write the whole functions. Okay, all the functions you can see over here. We are going to write it, how all the logic about it. Okay, so yeah, so we'll import it, hash include. Okay, so here is the So here is the no operation backwards, which is basically a null function. It would take a value, but it won't output anything. We'll use it in the place as a placeholder for the functions that don't have any backward function. Okay, like just to initialize a new scalar. Now onto this creating the initialization functions. Okay. Actually, this is a pointer function. We are defining the pointer of that function, which is basically the memory allocations. Okay. So it will take, as you can see in the actual function, I see an error over here. Okay, so here we are storing the scalar in a variable in self. Okay, it would take. We are basically not creating the values right now, not putting the values right now. We are just allocating the memory spaces in the RAM. Okay, since we don't have any values, we'll put it in later. We'll put it in afterwards. Okay, so yeah. Graph is 0.0, which is basically 0. Since it's a double, we'll write it like that. I am putting the auxiliary value as 1 because mostly we'll perform wherever we are going to use auxiliary value would be in a multiplication function. So anything multiplied by 1 is basically the number itself. So yeah, return. So, okay. Yeah, this was the initialization function. If you don't understand it, what I'm doing, you can just refer to the previous video. The link would be in the description, or you can just check out the header over here in the right top of the screen. So I've just written the whole code. Okay, functions are pretty basic. You can refer to the previous video for the explanation part. Okay, so the thing that is different in this implementation of scalar micrograd from the last one is that I have created a new struct, which is a dynamic array, which basically is the thing that it could grow the size of the array that holds the topo and the visited arrays. Okay, so yeah, we can increase it dynamically. Okay, more handy to use. And we have 3 of the functions associated with this, which are basically we want to export those functions. In export means we are trying to use in the other files. Okay, which is build topo, that would build a topographic map for all the values that has been created or that were part of the whole operation. Okay, and the backward is basically where we'll call the backward function of each of the scalar value. Okay, and print actually. Okay, so yeah, and now as you can see, the first thing we need is to initialize the dynamic array, and by initialization means I'm going to initialize it as small as possible. So we have a data which is a container of the pointer. We have a one-dimensional array that contains pointer to the scalar values. Okay, so basically we are not storing the values itself, we are storing their pointers, which is memory location to those values, since we don't have any values right now. Okay, so size is the property that is the amount of items are inside that array. Okay, so let's say we have a space of, and capacity is 10. Okay, so how these are different, which is 10 is the maximum size of items it could hold, and size is 0, which is basically the amount of values present inside it. Okay, so size would increase and capacity can also increase based on the need. Okay, so here we have a function that would increase the size of the array dynamically. Okay, whenever we need it, that it would increase. Okay, so first thing is we check if the size, if the number of items that are going to be stored inside the dynamic array, uh, if, if that increases the 10, if that increases the capacity of the array, we'll just start to increase the capacity by 2. We won't increase it by much, we'll just increase it by 2, and we'll reallocate the whole data and size of the tensor, scalar. Okay, so yeah, and to free that array from the memory, we have a basic free memory array function. Okay, so this is a function that is used for running the checks if that array actually has some values, or it's just storing those pointer values. Okay, so yeah, it would return if at the pointer location, if the value is present, it would return 1, and if it's not present there, it would return 0. Simple as that. Okay, now onto the build topo function. Here we use the dynamic array and the function dynamic array print to basically build a new topographic map of all the values that were involved in this whole operation, throughout the whole operation. So yeah, we loop through the previous size of each of the values, which is basically like climbing the ladder and moving. Okay, so yeah, and whenever we need more values, we just increase the size of the topographic map. Okay, and this is where the magic happens, which is the backward function. In this function, we revisit the created topo, and we pick out each of the values, and then we call the backward function, the respective backward function of each of the functions. That is, let's say if we did an addition operation, so we'll call the add backwards. If we did a power operation, we'll call the power backwards. Okay, so yeah, that's it. So now in the last tutorial, I just left it at this point. I didn't show you how to use it, or I didn't create any kind of neural network. So in this tutorial, I am going to do the same. No, actually, I'm going to make a neural network, and I'll show you how it works. Okay, so yeah, we'll create 2 more files. One would be the header, and one would be the main function file, which is C. Yeah, so as you might remember from the original Micrograd code, we had 3 classes. That one was a linear function, which was basically mx plus b, and then it was neuron, which is tagged linear functions, and then we had an MLP, which is using those neurons and the values. Let me show you this. Let me just show you. So yeah, you can see we had actually we had 4 classes, which one was the basic module class, which would store the parent functions for all of the subclasses, and then we had 3 subclasses, which first one was module, first one was neuron, which is basically y is equal to mx plus b, basic function. Okay, and then we had layer, which is stacked neurons one over the top of it. Okay, which makes one-dimensional neuron to two-dimensional layer. Okay, so and then we had MLP using those neurons and layers to create basic uh, MLP, which you can see. Okay. So yeah, now I'm going to create it in C. Okay. Yeah. So first thing first, we need to create a header file, which is basically where we store all the functions that we need to export and import. Basically, the blueprint of all the functions. Okay. So yeah. Okay. So here we have our uh, header file for the neural network uh, functions. Okay. So we have a struct. We have defined a struct which is neuron, not we, actually I. So I've defined a struct named neuron, which is basically multiplying the weight with the input scalar, and then we'll just add the bias if it wants it to. Okay, and also we have included the nonlinear, which is int nonlinear, which is basically asking if we want nonlinearity in our neuron or not. Okay, so yeah. Okay, so and then we have layer, which is basically a stack of neurons one over top of it, and the size, which will define how many neurons we are including in our array. Okay, and then we have MLP, which is layers, that is a stack of layers, and that would define how many layers of MLP we have. Sorry, how many layers layer we have in our MLP. Okay, so first thing is, as we need a neuron, and then we need initialization function, and then we need a forward function. Backward function we don't need because we have already defined it in the C, the scalar code. Okay, and then we need a layer, initialization, and forward function. Then we have MLP, which is initialization and forward, and also we have a free, which function, which would free all the previous stored values that were being used for creating our MLP. Okay, and then we have a zero grad, which would reset the gradients to 0. Okay, so in this code, you can notice two new things. First is tensor, which I'll explain you what it is, and this is scalar. So I've defined these two in the previous scalar header function, scalar header file. Okay, so basically everywhere I had to write this, you can see scalar pointer. Okay, so I can just write now a small scalar instead of writing the scalar pointer, and if I want to give a pointer to a pointer, which in case of multidimensional arrays or multidimensional tensors, so I've just created a new placeholder for that, which is named tensor. Okay, so nothing much. You can just use it as it is instead of writing those things. Okay, so now we're going to import our m.h. So now I'm going to initialize the neurons, and we will write the forward function for it, and then we'll repeat the same process for MLP and the layer. Okay. Okay, so now I'm done with the whole code. Okay, so now I'll explain you how these things work. Okay, uh, here we have the neuron initialization function, which is basically we are in where we are going to initialize a neuron. So uh, pretty basic. We have a neuron, and we are going to take the size of neuron and we'll assign a pointer to it. Okay, and then we need to assign the weights, which is basically would be the size of scalar, which is a basically a scalar. Okay, and the number of inputs. We are taking the number of inputs, number of values that would be inside the. Okay, so weights, which are basically the scalar values. Okay, so there would be lots of scalar values, so that's why we have this number of inputs. Okay, and then we have bias, which is basically 0, and we'll uh, as we move forward through the forward functions and to the number of iterations, we'll change it. Okay, and then we have number of inputs and non-linearity. Okay. Here we are going to initialize the weights. Okay, at this part we initialize the space for it, we allocate the memory for it, and in here I'm going to initialize the actual uh, values. Okay, we are going to randomly initialize the value, and this is the expression that I'm using. Then we are returning a neuron, which is basically a pointer, that's why I put pointer with it. And the forward function, it's going to return a scalar pointer, so that's why we are using small scalar. Okay, as I told you, I don't want to write it everywhere. It would have two types of inputs. First would be the neuron, and that would be the inputs. And as you can see here, neuron is basically a one-dimensional tensor, which is having lots of values inside it, scalar values. And tensor is also a one-dimensional array that would have lots of scalar values inside it. And we are going to initialize the bias for the neuron. I don't know why. Yeah, so okay, and yeah, so now we are looping through the each of the array, and we'll multiply the we are going to multiply the scalars, the first item from the neuron and then the other item from the input tensor, and then we'll multiply those and we'll sum the scalar. Okay, the bias. Okay, and then we'll free the remaining variables and output the, and then just output the new sum variable. Okay, and in this part, if non-linearity is there, if we want a non-linearity, then we'll here I'm using sigmoid. I'll tell you later why I'm using sigmoid. First thing, it's pretty basic, and the other thing is value sucks. Okay, that's my opinion. Cancel me all you want, I don't care. And then we have layers. Okay, so we are going to initialize the layers, which is basically stacking neurons one over top of it. Okay, and one is the input dimension, and then it would be output dimension. Okay, so here there is a pointer and then neuron and neuron outputs. Okay, and initializing neurons, and then there is a forward where we'll pick out the data from the pointers, and then we'll just multiply them. We'll put into the forward function of the neuron. Okay, and then there is MLP. So MLP has three of the inputs. One is the number of inputs, and then is number of outputs, and then there is number of layers. Okay, which is input layers, output layers, and hidden layers. Okay. And then there is MLP and the basic initialization process. Yeah. So in MLP forward, what we are going to do is we are taking an input of MLP, which is basically the MLP class, and the tensor input tensors, and then we are going to call the forward functions of the layer values. Sorry, the layer struct. Okay, and as we get the output, then we'll release the memory stored in the RAM. Okay. So Zerograd function is basically we are putting all the gradients of all the scalars that are involved in the that that are present in this weights and biases to the zero. Okay. So here you can see we are putting we are assigning all the gradients of the weights to zero, and here all the biases. Okay. So yeah, this would uh, print all the parameters that are present. Okay, basic function. Now I'm going to show you how to use all the 4 files that we have written, all the 4 files of code, and we are going to use it to create a new neural network. Okay, which I didn't do in the last tutorial. So I've created a new file which is main.c, and now you can see x's are the inputs and y's is the output, and it's 2-dimensional and it's just 1-dimensional array. And now we are going to define the layers, and then it's the MLP. Okay, I could just skip this part, but prefer this thing. I can just write this thing in here. That's not the problem. And we are going to 100 epochs, and learning rate is 0.01. Okay, so this is the loop, this is the training loop I have defined. Okay. So first thing first, I'm initializing the loss scalar, that would be 0. As the neural network progresses, it would keep changing. Okay, and now I have this so now here you can see I'm initializing the you can see all of these values x's. Okay, so this is a pretty basic array, simple array in C. Okay, and these all are double values. You can see let me show you. Okay, you can see double values. 3.0 is a double and 0.0 is a double. Now we want to convert it. Now I want to convert it into the scalar. Okay, so for that I have written this loop, which is basically it would loop through the first dimension, that is 4, that has 4 layers, and then it would again loop through each of the values, 3 values, and it would initialize them to a scalar. So now we have got our outputs, and now we can just call the MLP forward, and it would give us some output. It would return some output, and we have initialized the target scalars, which is basically a 1-dimensional array. So it's pretty easy to initialize it as a scalar. Okay, you can see it. Yeah, and now in this I'm checking the error, which is basically subtracting the outputs from the targets, and then error squared, and which is basically the loss. Okay, you can see after calculating the loss, we'll just free all the values that are not needed. Okay, so then we'll call a Zerograd, and after that I'm going to call backward, because we need to make sure that all the gradients are set to 0, because if we don't do that, it would accumulate more gradients in each step. Okay, so we don't want to have this problem. And yeah, this is basic to print the parameters. Okay, and this is epoch and loss, and these are the final outputs. Okay, since when the loop would end, the 100 steps are completed, then we'll have this as an output. Okay, so now I'm going to run this whole code, and I'll show it to you how it works. Okay, first thing first, we need to compile it. So this it's compiled, as you can see it over here. we got the .exe file, and then we'll run it. So yeah, you can see it will take off 100, and loss decreased. Actually, loss was increasing, maybe because of wrong initialization. Run it again, and this time it's still increasing. That's pretty strange. I think there is some issue, some kind of bug. We'll just see. This is a different. Recompile it. This time we can see when we used tan-h as an activation, loss decreased. It changes quite significant, and at the last we get the final outputs. Okay, so I think I can see loss increasing and decreasing, which is basically it's fluctuating. You can see it got to 1.0 and then it again rise to 1.1. Okay, see, it's increasing and decreasing. Okay, so it's fluctuating. There's no problem. And yeah, one more thing. Why didn't I use the ReLU function? I'll show you. Okay, as you can see it over here. Sorry. So somehow I don't know why, but some bug is over there in ReLU function, or maybe it's just because of vanishing gradient problem. As soon as the values reach, the loss reaches 4, the whole MLP crashes, and I get the output 0 0. All the outputs are 0. Okay, so I can't figure out what is happening with this. Maybe it's just a vanishing gradient problem, or maybe it could be something else. And if you can find it, the bug in my code and anything you can just want to improve, you can just tag me on Twitter with the improvement, or you can just DM me on Twitter. Okay, so this is it. This was the whole tutorial, and I hope you learned something from this. And if you want to check out the Git repository, I've uploaded all the codes over there. You can just check it out. The link is in the description, and you can follow me on Twitter if you want. And if you like the video, please do give a thumbs up, and subscribe to the channel if you want to see more videos like this. In the next video I'll try to implement this whole thing in C++ just for fun. And then I have a lot of videos coming up, and I have lots of videos coming up in the future, because I've worked on lots of projects, lots of interesting projects, and I'll love to make videos about it. Okay, so yeah, do subscribe the channel.